All right, so this is a kind of a tutorial of sorts for a model that I found on Too Tall Toby's website as a practice model. So here's a drawing of his practice model here. It's a formed sheet metal part. And actually I was watching his tutorial on this and I figured I'd give it a shot and see how it worked out in Alibre Sheet Metal, and tried to accommodate or use some of his techniques, and found that they did not work the same in Alibre that they did in SolidWorks or Onshape. So anyway, I'll go through the steps that I did to create this part. So just an overview here. We've got a 4mm thick material with a 4mm inside bend radius. We're going to be shooting for our 1028 grams at plus or minus 10. That's the 1028 is the result he was getting. He was pointing out that this 26-degree taper on these end flanges begins at the tangency of the side end face and the bend. And you can see that on this drawing here a little bit on this view. And it continues down around and goes through this bottom bend and stops at the tab of the bottom flanges there. Also, these rectangular holes are actually they're square holes, are 30 millimeters by 30 millimeters, and there's a 2mm gap between the flange and the edge of the cutouts, and then they have a 7mm radius on the outboard side of them. This slot going through here on the top flange, the slot is 154 from center to center, and then as you measure between them on the bottom flanges, your result is supposed to be 206. So we'll go through how to put this in here, and in Alibre we'll do an unbend and rebend to accommodate that. Then on these flanges on the side, the length of the tab is 15, the angle is 75, and they're bent to the outside. And then they're 110 centered on this side of the part. So the width of the top panel here is 80 millimeters, and then he's ending up with a 112.52 on the bottom panels. Bottom tabs here as the final width. So we'll see how close we get to that. So without any further ado, let's take a look at the part that I created here. Okay, so here's the part that I ended up with. So let me just roll this back to the beginning, and we'll kick it off with the first step that I did was create a sketch. So that I ended up with the requisite 170 millimeters along the top at the apex of this bend. Then I put in a 60-degree flange sketch on each side, and I made those two equal. And then the bottom flanges, I made them coincident with the origin and 170 degrees between, and put in equal constraints between those two. And I've got a dimension at 65 millimeters high, which is the required 65 millimeters height that we need here. And then with that, I created a contour flange, and I extruded that to the total width of 112.52. Now, one thing I'll point out here is that when you're using the contour base flange, the linear figure as tab is usually set to auto, and I usually leave it set there, but when you go to get the flat pattern, it can give you some odd results. So what you want to do is select manual, click in this box, and then select a horizontal line, and that will give you a part that will flatten parallel to the XY plane, and it won't be skewed off at some weird angle. And we'll cover that later in the video. So with that said, then so I've got this basic shape. First thing I did is I went in and did an unbend, and basically you go to unbend, and I just click on my top face here as the fixed face, and then hit select all bends so that everything would unfold. And the next step was putting in this sketch so that I could get get the 26-degree cut or slope on the end faces. So my sketch goes from this tangent, this edge of the bend line to this line here. Those are going to be the tangent points of the bend to the side faces. And then I dimension that 40 millimeters off the center, or off the origin. And then at 13 degrees, I just extended that out to where it came to the edge, and then put a line across there. So now that notch cuts off that part, and mirror it. Now we end up with an 80 millimeter wide tab in the middle, and then 26 degrees on their side faces. So we measure between our side faces. If I can get the face here and the face here, go to angular, we've got 26 degrees, which is the required angle that he needs there. Then we go to put in our cut, and this is where I know on his video he was saying this was kind of tricky, but anyone that understands the reason why they put unbend and rebend in sheet metal tools, you understand how to use this. So what I did is I created this as a rectangle on this side, and I converted these two end lines to reference figures, and then I sketched in some center point arcs to complete this off as a full dimension arc. Then just drew a rectangle around it, and I mirrored that to the opposite side, and then I applied my 154 dimension between those two. So I've got 154 on the top surface. To get the right dimension on the bottom, what I did is I open up my equation editor, and then I put in open parentheses, my 206 is the dimension that I need, and I subtracted the 170 dimension, which is the dimension between the ends of the flanges, close parentheses, and divide that by 2, and it gives me 18 millimeters, which is the distance that now from this center of this radius slot to the edge of that panel. And then it was a matter of cutting that through. And the next step is to do a rebend, which is basically just select the rebend tool and just click on select all unbent bends, and it folds the part back up again. And if we measure between these two slots here on the bottom end, we end up with our 206 as the drawing requires. Next thing I did was cut these two holes in the top for the top flanges, and again I used a mirrored sketch. I put a 30 millimeter square in here, and then I centered this on the origin with going with constraints, go to midpoint. It's like these 2 points and then the origin, thanks to Ex Machina for that tip. And then I mirrored that to the other side, and I was able to dimension 40 millimeters between the two edges, and they stay centered on the part. And then it's a matter of doing the cut to thickness on there, and then we're done with the holes. Then for these flanges, basically I selected the two inside edges, set my flange alignment to adjacent, and since the dimension here, we're at 65 on the total height, 88 to the top of the flange from the bottom, leaves us a 23 millimeter flange from this top surface. So using inside dimension, I set it at 23 millimeters, and then on my offsets I put 2 millimeters in each one. That gives me the 2 millimeter gap on each side, and it's set to 90 degrees, and that takes care of that flange. Then for these flanges, again, before I let me back up here. Before I put these flanges on, I selected the edge here and got the length here at 160.762, because I'm going to use that value to calculate the length of these tabs or flanges. So what I did here, again, I'm going to do a bend that's adjacent so that the bend is outside the material. Now here we're looking for the tab length at 15 millimeters, and for the length offset, again going to the equation editor, I've got my open parentheses and 160.762 minus the 110 flange length, close parentheses, and divide that by 2, gives me the 25.381 offset dimension. Then since this is, then I made this dimension equal to this one just by keying in its label in there, D116, into this box, and I've got a flange that's centered on the panel, and that is in fact 110 millimeters long. And the final cut that we did here was a 10 millimeters diameter hole through the top flanges, and that's just basically a 10 millimeter circle drawn on this face with a vertical constraint between its center point and the origin, and dimensioned at 80 millimeters off the origin, and cut through all. Then it's just a matter of throwing in some corner flanges, or corner rounds. And on here, notice that it says faces and not edges here. So if you want to select all the edges on this tab, you just grab an edge or a face, and it grabs all those edges and applies a radius to them. And on the bottom, again, all the remaining edges get a 7 millimeter radius. So it's a matter of selecting all these different edges to get the radius, and in some cases you can select just the panel itself and it'll radius the corners for you. So that was kind of the quick and dirty on how this part got made, and I ended up with a total mass of, he said 127.4, which is 0.6 millimeters off of his requisite 1028. So we're well within tolerance on here. So what I want to do is show a couple of things that I noticed differences between the way I created this and the way Tony was showing on his tutorial. Okay, so let me start a new part here, and I'll just set the sheet metal thickness to 4 millimeters, and we'll make the bend radius equal to thickness, and okay that, and then we'll just create a sketch here on this XY plane. And actually what I'll do is I'm only going to create half of the part to illustrate the major differences that I found here. So I want a vertical between this endpoint and the origin, and then I want a horizontal constraint between the origin and the end of this line, and we'll dimension this to 65, and this is going to be at an angle between these two at 60, and the length on this line here 170 divided by 2. Okay, and then we'll select our contour flange tool, and we'll change our depth to mid plane and our width to 80 millimeters, and then we want to reverse the thickness because we want the sketch line to be on the outside, so we capture the 65 millimeter height and the length to this intersection or this apex. Okay, so now let me okay this, and now here's one thing that I want to point out. So since I started this sketch with a horizontal line, and it says the figure tab is auto, if I switch to manual, it's saying that it's going to pick up line 1, which is this horizontal line, to create the flat pattern. So when you do a flat pattern, it's just going to align that nicely with the XY plane. If I had this pick this other line here, it's line 2, and go to flat pattern. See how it's skewed now because it's got this line is at an angle, and it's kind of just throws it up there. I don't know, it seems to me like it's arbitrary, but I imagine there's some reason for it, how this works. So let me switch this back to line 1, contour flange, edit, select line 1, okay, and flat pattern looks good. So now here we have our width here is at 80 millimeters, and what Tony was saying, if you are in his tutorial, he was actually creating a sketch on this panel, and we'll just convert this to geometry, and then we'll come in here and we'll draw a couple of lines. Didn't get my lines here, maintain, and select OK. Okay. Now we'll have a coincident from this point to this point, and from this point to that point. We'll make this horizontal, and this will dimension at 13 degrees, and create a tab on there, and then we'll mirror this tab about the center plane, and here we select our edge there, and we get a length of 112.523, which is what he was showing on his drawing at 112.52 as the width on that. So I'm assuming that his method gave him that length, and that's what he stuck with on the model. So now we need to add a flange, return flange down here. So if we come up here and we select our edge flange, and we'll grab this line here, and I'm not sure what the length is going to be, but if it's going to be, we'll say 45, and then we need a length, change that to 120, but now we need this panel, this flange, to be up here on the line with the origin, so we need to change the position of the alignment. So if we change this to outside, that's still not there. If we go to inside, then we get it lined up with the origin, and our length on the leg length really doesn't matter, because I'm going to trim this back to the 70 from the middle, or so that it lines up with the 170 divided by 2 on the top there. So we'll apply this and close, and then on here we'll activate a sketch, do a rectangle, and we'll just throw a quick dimension on here, 170 divided by 2, and we'll do a cut to thickness. So now we have that length, and we have our height from this panel to this panel. We have our delta Y is at 65 millimeters, which is what we wanted. Now here's the kicker, is that we measure the length of this line, we're at 108.698, or round it off 108.7, which when you look at his drawing, 112.52 plus or minus 1, so the shortest we can be is 111.52. So using his method is going to put this out of tolerance for length. The other thing I wanted to show is that his part here, he's got 30 millimeter rectangle or whole squares cut out here, and if we come in here and try to use our sketch bend tool, we're going to have a problem. So if we do a sketch here, say 30 by 30, and then we'll use our midpoint constraints between point and points of those lines and the origin to center that, and then we'll just dimension this to 20, and go to sheet metal and grab our sketch bend tool, click in the bend line box, and then we'll select our edge line over on this side. And now we want to have our flange adjacent, so that it's adjacent to this 20mm line. And then our gap is going to be 2mm. So if you notice what's going on here, when you use the sketch bend, the sketch is actually defining the size and shape of the tab or flange that you're bending. The offset width, or the gap width, is going to define the size of the cutout. So if we need this cutout to be 30mm, then we need to reduce the flange width by 4. So this has to be 26. So let me come in here. We'll change this to 26. And now we have a length here of 30mm. Now the flange length or height here, we need this to be 23. And our delta Y is 25.643. And we need that to be 23, so we need to subtract 2.643 off of this flange. Minus 2.643, and let's see what happens here. We'll measure it from here to here, and we've got 23, and from this point to this plane is 88, which is what the drawing calls for. And then to make it even simpler, let's edit this sketch, and we'll put in some 5mm fillets on this sketch rectangle, or well, it's rectangle now because it's not square anymore. And then we end up with 5mm fillets on the tab and 7 on the cutout. And when you flatten this, oh, that was weird. So when you flatten this, we end up with 2mm gap on the sides, just like we keyed in, and 2mm on the end, because the sketch bend is going to treat that 2mm all the way around. But if you look on my original part, when I do a flat pattern here, and I measure that cutout, I've got 2mm on the sides, but on the ends I got 2.643, which tells me that in his initial design he did not design this as a sketch bend. It was set up as individual features of a square cutout with individual flanges added to the part. So you cannot use a sketch bend to create this feature on this part. So anyway, those are the couple of things I wanted to point out, differences between his tutorial and how you can create this part in Alibre Sheet Metal. And so I hope this helps. If anybody wants to take a challenge on his website, feel free, and hope some of these tips help you out on sheet metal. So talk to you later.